Hi everyone, once again, today we're going to do beams as well as slabs. Now to create beam, I'll go under beam uh, and then select normal beam. Again, uh, the width of the beam will be 250 mm, same as the width of the column, but for the depth, 500 is too big. Let's say 450. Then I click update. Then I'll create my beams. Okay, one beam 250 by 40. So it is a continuous process. To there, to there, to there, to there, to there, to there. To there. If you want to stop, you just press outside and click and to stop the motion. Now that was the manual way of doing it. If you just want to automate, you can just do this. Control Z, again beam, say 150 date, and then I can create this one here manually, and then for the other ones I can hold control down, then I'll drag this here and release. Okay, see, I've done that for you. Again, that, again. Okay, close. That is completely done. Remember that once you have a shear wall, you don't need the beam. That's why when if I automated it, it didn't put any beam here, because the shear walls go throughout. They're already a structural member, and this is a lift shaft area. Now, now that is all about beams. This is just all about modeling. Once we come to loading, I will tell you how you will load the beams in case of line loads, in case of point loads or uniform distributed loads. That is, you will load now the wall loads for the brick walls, or in case of a brick wall, you have a block wall or anything that slides along here. So we will put wall loads and also we put wall openings. Now after completing this, we go to back to modeling, we go to slabs. Now in order to create slabs, it will tell you you have to assign load cases must be defined before you like to do slabs. So I say yes, and then it will bring me this load combination. The other way of getting this prompt, I'll cancel here, you come here to loading. Okay, I'll just say no. We'll come here to loading, and then to tell you, you come here to load cases and combinations. You see the same prompt. So here, the first thing you're going to say, you add. Sorry, the first thing you have to do is to press on load generator. So here we have different combinations. You have dead loads, live loads, and in terms of vertical loads and horizontal loads, you have wind loads. If I select wind load, it will be live. Okay, we have soil pressure. I can select soil pressure and it will be live. Remember, this is a United Kingdom code I've used, so that's why the seismic load is not there. If there's another code, then if I select here, then it will be live, and I'll put the it will put the load combinations here, and also the factors to which you are going to multiply. So for horizontal loads, maybe currently the area which I'm in, there's no wind load, so I'll not put that. I'll just deal with the vertical loads, that is with load case G and load case Q, and the coefficient which you usually use is 1.4 multiplied with the factor of the dead load that you're going to provide, and 1.6 for the factor that you're going to provide for the live loads. And I say OK. Once I press OK, it will appear here. Okay. Once that is done, just press OK. Back to modeling slab. Now it will accept me to model slabs. Now here under slabs, you have to see something here. This is the label as always. One represents story one. One here represents the first slab. Here you have a slab type. You have slab type 1 to 12. You have slab type 1 that is continuous on all 4 sides. Slab type 2 that is continuous on 3 sides and discontinuous on one side. On one side, which is the longer side, and we have slab type 3 that is continuous on all the sides and discontinuous on one shorter side. We have type number 4, which will be a slab that is continuous on two sides and discontinuous on two sides, both the shorter and the longer. Then we have two side continuous, which are longer sides, and the shorter side is discontinuous. Then we have one side continuous, that is the longer side and discontinuous on the other side. Then we have a shorter side that is continuous, but the longer side is continuous. And then we have a shorter side continuous, while other three sides are not continuous. And then we have tab number 9, which is discontinuous on both sides. And number 12, this is a cantilever slab. Okay. So under normal circumstances, while working with the software, just leave it under slab type 1. And then later on, I will select all the slabs, and then you right click and you just tell it to automatically select the slab type for you. So here, this is the thickness of the slab. 120 is too low, so let's put it at 150 mm. This the relative level of the slab, it means if you put it 0, it means that the slab is flashing on the top side with the top side of the beam. It's like you're creating a monolithic structure. The cover, let's put 25 per bs. This is the label position, that is the naming of the slab. Do you want it to be at the center? Do you want it at the top corner, or the left, or top right, left bottom, right bottom? Many times we name the slab and the labels at the center. Now the insertion method of a slab, there are 4 ways of inserting a slab. The first one is the beam region, that will be automatically there. The other one is the axis region. Here, look, there's axis region, there's beam region. You can pick axes, you can pick points, or you can pick closed slab edge. Okay. Currently, it was under beam region. It means anywhere where beams are creating 4 edges, it will accept to create a beam, to create a slab. So that is the beam for beam region. You can use that, and once you've just picked that, I'll just come here and select and place the slab. See now, this direction here of the cross shows you that this slab is a two-way spanning in the x and y direction. And also these lines here, these are the yield lines that show you uh, the lines of failure of this slab. In case it fails, it will just fail this way. Okay, that is by using beam region. So I can use beam region to put that. Can put that also. Then I can just change the method of insertion. Then I can say I can go to axis region. When I say axis region, when I say axis region, you have this axis, this axis, this axis, this axis. When I select there, also it will pick. It means axis 3, axis 4, and axis E and B. It will accept. Another way I can say pick axes. If I pick axis, I will say like this: I'm picking axis 2, axis 3, axis D, and axis E. Sorry, let's do that again. Say pick axis. Axis 3. Let's do it again. Pick axis. Do again slab. Then I say pick axis. I go to axis 3, axis D, axis E, and axis 2. Sorry, slab. Pick axis slab. I'll pick axis 3. I'll pick axis axis D, and then I'll pick axis 2, and then axis D again, and then I'll pick axis 2, and then axis E, and then back to axis 3. You get your slab there by picking axis. So you have to do it in a clockwise direction. You pick 3, you pick D because it is intersecting here, and then again I picked 2, I picked D, it is intersecting here, and then I picked E and 2 because it's intersecting here. Then the last part is I picked axis 3 again because I had already picked E to complete it. So you 3D to E. That's done. The other method again is to pick points. Pick points. Pick points in a clockwise direction. So I pick here, 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 and here. Okay. So just back to my beam region method to make it quick. Select there, 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 and there. Then we close. Remember, this is the building is going to use the lift. So here is your lift. This is supposed to be open, so don't put a slab here. Now, what I was telling you is that if I come here to my quick filter, and then I deselect all, I say select for me slabs. So once I hold down my left click, say this, it will select only slabs, and then I will right click, and then I'll come here and say set slab types automatically. Yeah, just say apply to a slab in the story. Okay, you see now it has now specified the slab. The first slab is type 3, the second slab is type 2, the third slab is type 4, type 5, type 7, all over. Say okay, so you don't have to have the trouble saying here how do I put, let me look here, if here it's going to be, here it is discontinuous, yes, continuous, and I'll choose this. You just place the slab by using type 1, then it will select for you. Now, once that is done, I want to show you how to put slab openings. Maybe you have a place where you have to put a duct for electricity or for networks in the cell. What you'll do is come here and pick maybe a cycle and come here and draw it. Okay, once you've drawn it here, you've already, it is selected. Then you go to properties. Select this, select properties. Okay, I want to show you on how to create slab openings. Here it is. You come to here. There's a slab opening. There's a type. There's a rectangular, circular, or polyline. The same thing which is seen as here. So I go to a rectangular. I select there and I drag it. Now, as you can see here, it's a slab opening. Once I select this, I tick here. I can make like a slab step. Maybe I say to go up by. I can even put also a fill load. If maybe I say it is 20 kilonewton per meter square. Then I say update. In order to see this, I go to plan view, to 3D view. Do you see this here? This here. You can play around with it. Look here. You can say 200. Say update. Do you see? Or it can be a depression. Let's say negative negative 100. Let's say update. You see? Or it can be a hole. If I take this, I'm sorry, if I put here 0, 0, 0, and here I put it 0, and I say update. See, it becomes an opening. To become an opening, do you see it there? It becomes an opening. Close. See, it becomes an opening. You can put your cables there, or if they are waste pipes, they can pass there. So you can design for this. The other thing that I want to bring to your attention before we end this course, this lesson, is back to plan view. When you're creating slabs, when you're creating slabs, before, if I'm saying here slab, you see this part here, it's called loads. The self weight of the slab will be automatically selected according to the thickness here. Say put 150 in the plate. The self weight will be calculated, you see. And for the dead load here, I can name it. Be it maybe it is a flat roof, maybe it's a room, it's a terrace, or a balcony, or a large slab. And then I can place the load here. Say it is 1 kilonewton or 2 kilonewton. I can press it there. And for the imposed load, this is being fed according to the code that we've been using. So if you come here and right click, see it will give you different types of live loads. If it's a domestic use, it's a residential building, bedrooms or dormitories, hospital area, toilet areas, billiard rooms, communal kitchens, balconies, banking halls, anyone that you choose, it will give you the its dead load. Okay, if uh, from there, now we can move on forward to analyzing your slab. So remember, it is very important to put the loads. Here, that's the general dimension of the slab, but here you've got the loads. So we have to put any dead loads that are contributed and any imposed loads. You have to put them here before going on. Most of the time, we use 1.5 for the residential or for many of the communal areas. If it's a residential building. So you have to put that a dead load. You've put also a dead load in case of tiles or floor screed or any floor finish that you're going to put. You put it here. You put it here as a dead load. This dead load here is only for the self weight. It will not measure or it will not count for the finishing that you're going to do. So if you're doing screeding or tiling, you have to put the dead loads for the tilings or floor screeding. That I will close. So from there, I will show how to create slabs. On the next lesson, I will show you on how to create ribbed slabs as well as flat slabs. Thank you for joining today.